Welcome back to STS. In today's video, we're going to solve the following trig equation by finding all of the solutions. Here we have cosine of 3x times cosine x, and that's set equal to negative sine 3x times cosine x. First thing I want to do is move everything to one side. So I'm going to end up adding sine 3x sine x to both the left-hand side, and here I'm going to do that again on the right-hand side. So sine 3x sine x. So I'm going to add these two together. In doing so, this right hand side goes away and becomes 0. On the left hand side, I end up with cosine 3x cosine x plus sine 3x sine x, and that there is going to be set equal to 0. And what I should notice is that this here is actually going to be the difference formula for cosine. So this here can be simplified down to cosine 3x minus x, and that there is set equal to 0. At this point, I can combine like terms inside of my parentheses here. So this here is actually cosine of 2x is equal to 0. And what I want to do now is just do a substitution to try to make this easier to solve. So what I'm going to do here is I'm going to set theta is going to be equal to 2x. So I can rewrite this as cosine of theta is equal to 0. Now, what I want to try to do is figure out what are the values of theta that make cosine 0. And what I'm going to do is fall back on my unit circle. So let's just do a quick sketch over here. All right, this here is 0 and 2 pi. Up here is going to be pi over 2. Over here to the left is actually pi. And then down here at the bottom is actually 3 pi over 2. And then I'm going to draw in the unit circle, and I'm going to fill in these places where the circle actually crosses the axes. So here at 0 and 2 pi, we see the x value is going to be 1, the y value is going to be 0. Up here at pi over 2, the x value is 0, the y value is 1. Over here at pi, the x value is negative 1, the y value is 0. And down here at 3 pi over 2, we have an x value of 0 and a y value of negative 1. And another property that we need to remember is that the x values are cosine theta, or in this case just cosine theta, and the y values are y is equal to sine theta. So these here are cosine values, and these here are sine values, and that's true for each one of these points. So for this So for cosine theta to be 0, we need an x value that's going to be 0. And we see that x is 0 up here at pi over 2. We have x value of 0, and x is 0 down here at 3 pi over 2. So those two locations are going to be the solutions for this particular problem. So let's just rewrite it here. Pi over 2 and 3 pi over 2. But what we have to do is to make sure we switch back to x, because right now everything is in terms of theta. So let's go back to x. Well, and to do that, let's write this out. Theta is going to be equal to pi over 2 plus 2 pi k. And 2 pi is the period of cosine, and k is just an integer that represents going around the unit circle multiple times, basically stating that we have an infinite number of answers. And for the second equation, that's going to be theta is equal to, and this time it's going to be 3 pi over 2, and again plus 2 pi k for the same reasons. Now let's just switch colors, and I want to go from theta now back to x. So here we see that theta is equal to 2x, so I have 2x pi over 2 plus 2 pi k. I want to get x by itself, so I divide each one of these terms by 2. In doing so, these 2's cancel, and I have x is equal to pi over 4 plus, and again these two 2's cancel, and pi k. So this here is one of my solutions. And now let's work on this second equation here, and we're going to make the same substitution. Theta is actually 2x, so I have 3 pi over 2 plus 2 pi k. I want x by itself, so I divide each term by 2. These 2's cancel. I have x is equal to When I resolve this, this is actually going to be 3 pi over 4 plus, again, these 2's cancel, and I'm left with pi k. So these two equations here, when used together, will give us all of the solutions as we go multiple revolutions around the unit circle for this particular cosine function. Alright, that sums up this video by Speller Tutorial Services. Please friend us on our Facebook page and definitely subscribe to that YouTube channel, Speller Tutorial. And as always, guys, thank you for watching.